Hello. Last class we started failure mode and effect analysis. Today we continue it. The contents of today's presentation, we will revisit what we have discussed in last class first, and then I will give you another concept called how to select the important or significant failure modes. Then last class we have discussed about that bottom up approach for system breakdown. Today I will give you the top down approach. Then the parameters for risk priority number calculation, that is probability, severity and detectability. So, those qualitative scale will be shown to you, and then how you will document the total FMEA analysis, that format will be given, and finally, the calculated RPN will be used to prioritize the failure modes using Pareto analysis, that we will discuss. If you recall yesterday's that last lecture, yes, what I have taken yesterday, that what I have told you, that failure mode means the ways the component of a system fails, and then switch failure mode, motor failure mode, human failure mode, and with reference to the compressor system different component failure modes we have seen. So, we are starting from that point. So, now there can be multiple failure modes, a large number of failure modes will be there. So, will you go for failure mode and effect analysis of all the failure modes, or is there a way to decide that which are the failure modes or which are the component failure modes that will be important to consider for detailed FMEA analysis? So, you put certain questions. Questions are like this: will a failure of the system result in intolerable or undesirable loss? You have your big plant, big organization. You can divide it into the several systems, then system to subsystem, then up to component level. Now, when you are talking about at a particular system, then when if the failure of that system result in significant loss, then that is basically the point of concern. If it is not, forget. If it is yes, then you divide the system into subsystems, and then you all again ask question: will a failure of the subsystem result in intolerable, undesirable loss? If no, document and end the analysis. If yes, then divide the subsystem into assemblies, put similar question, and in this manner you go on breaking down, like divide each subsystem into assemblies. Will failure of the assembly result in a no, then end. If it is yes, divide each assembly to sub assembly. Again, if a sub assembly will not result into any insignificant loss, stop, and in this process you proceed, and finally divide each sub assembly to component and sub component to that component. Those are the component you select, and then further you component to part also, that breaking down is required. So, that means it is essentially those components which result into loss. That loss may be at the subsystem level, at the component level, or at the system level. If any component failure has system level loss, then it is very important component. So, last class the system breakdown concept we have discussed with reference to bottom up approach, where where we have shown you that system, subsystem, subsystem, then component to part. You can go for functional approach. In case of function, there will be system have different functions and then different sub functions and then sub function up to component level functions. Okay. That way you proceed. With reference to this, I am not explaining this further, because you know this system we have explained in last class. With reference to this, what is the functional breakdown? You see, compressed air system. What is the purpose of this compressed air system? Provide compressed air at 100 psig, remove moisture and contamination from air. These are the two things to be done. Now, when we talk about provide compressed air, these are the sub function. So, function sub function: intake, air intake, compress air, contain air, distribute air. So, air intake, compress, contain and distribute. The difference you see: intake here, this one, and then contain and distribute here. So, provide compress air, remove moisture, contain compress air. So, these two. So, we have broken down into subsystem level, and then you see that provide compressed air will require first that you must have the compressed air, compress it and then distribute, contain and distribute. And removal of moisture is another function where remove moisture and remove contaminants. So, accordingly you see the differences are taken place. Okay. Now, you may what you will do when you go for FME analysis, you may start with that, suppose distribute air. During distributions, what are the different ways this will fail? That will be the failure mode, functional failure mode. The methodology part I have discussed in last class, but today our primary focus is that how to find out the severity, probability and detectability and calculation of RPM. So, what is required? You require to have some scale. So, scale for measurement, scale for measurement. It can be objective, it can be subjective. So, we will see some subjective scale. So, what are those things? So, let us repeat it. We will be providing you scale for measuring severity, which is basically determined based on the effect of failure mode. We will be giving you scale for probability of occurrence, which will be determined by the potential causes of failure mode, and detectability of that failure mode, that depending on that design current conditions and design verification process. I should not repeat this again. This is compressor related failure modes, pipe related failure mode, control, relief valve. We have considered only compressor subsystem, and we are considering that bottom up approach, that is hardware approach. So, how many failure, if we are interested only in this compressor, then how many failure modes are there? 1, 2, 3, 4, 5, 6, 7 failure modes. Okay. So, with reference to compressor, we will show you all the calculations. Now, first one is the probability. So, this probability we are giving you basically 10-point scale, and it is taken from a paper. I think which paper is this one? I think in the reference you will get it, that Basic FEMA, no. Then Goodman Management Mindset Universities, Wheelwright and Clark, this one, the third one. So, we have taken from this. Okay. So, you can go through this and you may find out something more. What is happening here? We are saying that the probability of occurrence is having 10 different values, means 10-point scale we are using here, 10-point scale. So, it is basically in order of probability of occurrence. If it is 1, this is basically remote probability. If it is 10, certain probability. And in between the degree of occurrence, the probability of occurrence is less. So, remote probability 1, low probability 2, moderate probability 4, 3 or 4 depending on the situation you have to give, moderate high probability 5 and 6, moderate high probability, very high probability 8 and 7, failure is almost inevitable 9 and certain probability 10. So, these are all subjective description, but you must have some reference so that you can how to put value 1 or 10. This is what is the failure with reference to potential failure rate, it is given. What it is given? The 1 means failure almost never occurs, no one remember last failure. Low probability of occurrence, failure occurs once per year or 1 in 1000 operations. Trials, failure occurs once in every 3 months or 1 in 500 trials. Failure occurs once per month or 1 in 100, once per month per week 150, every 3 to 4 days 1 by 10, at least once a day 1 by 5. So, you must have this experience, and when you are doing FMEA analysis for your system, whenever you are considering component, you see that what is the failure rate, under which category it is falling. If you find that it is basically that failure occur once per month or 1 in 100, so you can put 6 or 5 depending on that. Means if you think that no, it is higher side, means it is obviously that 1 in 100, then 6, or you think that no, it may be little less, give it 5, because it is the subjective one. So, for a particular failure mode, you will first find out what is the probability of occurrence, it may be 6. So, failure mode 1 probability of occurrence is 6, P is 6. Then what you require? You just think the example here. For compressor, these are the failure modes 1, 2, 3, 4, 5, 6, 7 failure modes. Now, what is the probability that external leak will occur? So, we are giving it moderate. What is the probability that external rupture will occur? 1. What is the probability that fails to start? Again moderate. So, like this, depending on the system knowledge, operation knowledge. So, you are finding out that these probabilities with reference to this scale given. So, for all the failure modes reference to compressor, their probability is now defined, probability value is quantified, though subjective, but we are putting a numerical value between 1 to 10. Then effects. What is effect? Effect is the severity. If a failure mode occurs, what is going to happen to the system? So, here also from the same reference we have taken 10 point scale, 1 no danger to 10 extremely dangerous. In between slight danger, low to moderate danger, dangerous, very dangerous, like this. Then what is the description? Description is given here. That means no danger means failure causes no injury or and has no impact on the system. Okay. So, maybe at the beginning you may eliminate some of the things while selecting that what are the modes you will consider, but even then something will remain, and in that case if you find that the thing is like this, no danger, put 1. Like 10, failure could cause death of a customer, so it is a fatality case. So, you give it is a extremely dangerous, put 10. In between you find out. Sometimes what happen, let it may be a 6, failure causes minor injury with some customer dissatisfaction and or major safety system problems. Okay. So, need not be that it need not require that you will follow this particular scale, 10 point scale. There can be possibility that you may go for 5 point scale, 1, 2, 3, 5, 4, 5, because when you are using 10 point scale, so many combinations are there, so many minor differences will be there from one level to another level, you may get confused. So, in that case it is better to go for 5 point scale. If you find that the people, the experts who are basically or the team members are more comfortable in 5 point scale, then you take 5 point scale. So, what will happen, you have to, that means your so much, that mean the breaking into the 10 different levels will not required. Okay. You may start with your slight danger, moderate danger, and then very dangerous, extremely dangerous, and then lower one may be the no danger. So, 5 point scale possible, 3 point scale possible also, 7 points possible also. So, you can create your own scale and give some severity as well as probability and detectability values. So, with reference to our example, external leak does not produce compressed air at desired pressure and volume if there is external leak. So, this is the effect. So, it is low to medium. So, we are giving 4. External rupture, you see property damage, injury and death, this is a huge one. So, effect is 10. Like operates at degraded performance, does not produce compressed air at desired pressure and volume like this. So, your severity is 4. So, you have to know that the occurrence of a mode, what level of loss to the system is going to happen, and accordingly you put the value from the 10 point scale given. Then detectability. Detectability case, if the failure mode is easily detectable, then what will be the value? The value will be low. So, when you move up, when if detectability decreases, then your risk increases. So, here detectability high, this is detectability and this is risk. Detectability increases, risk decreases, detectability decreases, risk increases. So, that is why what happened, we have used the reverse scoring. When detectability is almost certain, you are putting the rating 1. When it is no chance of detection, you are putting 10, and in between similarly very high, moderate, remote, very remote, no chance, like this. And the description is given here. When no chance of detection, there is no known mechanism for detecting the failure. Like suppose you think of that any system where suppose different gases are used, there may be leakage of gas and you have no detector sensors put there which will ultimately give you an alarm that there is a leakage. So, then what will happen? The leakage will not be known, so that kind of mechanism. For example, in the pressure tank system, whether overpressure conditions can be detected, yes, because alarm is there and pressure gauge is there. But suppose you think that there is no alarm, no pressure gauge, what will happen? That overpressure condition is not detected, which may ultimately lead to the tank rupture. This is the extreme failure, dangerous failure mode. So, similarly, almost certain there is automatic shut-off or constraint that prevent failure. Okay, it will not happen even if that failure the system is such that the failure is prevented. Okay. So, we have defined probability, we have defined severity and we have defined detectability. Now, externally for the system compressed air system, external leak detectability high, rupture almost certain, fails to start, like this. Suppose operate degraded performance, it is difficult to detect. So, accordingly the detectability ratings are given. So, then what happened? It simply shows that you have given P, S and D, it is known now. P, S, D known now. What is P? P is probability, severity, detectability now known. Now, what do you require? You require to compute RPN. What is RPN? RPN is probability times severity times detectability. So, RPN is something like this. RPN is this. So, you will by, if it is probability, so with increase in RPN, probability RPN increases, with increase in severity RPN also increases, but with increase in detectability RPN is decreasing. That is why we have used the reverse scoring here. Here if it is almost certain, you are giving 10, here also 10, but here you are giving 1. So, okay. So, for different failure modes, probability, severity, detectability given, you multiply. 4 into 4 into 4 is 64, 10, 7 into 4 28, 112, 30, 180, 168. So, whose RPN is maximum here? Operates at degraded performance, which is 160. So, if you do not calculate RPN, if you simply think that this is the failure mode where you should concentrate, then obviously you will first say that this is the place to be concentrated because it is huge severity. But when you have seen the probability that the chance is very less, because the design is with high safety factor it is designed. So, probability is less. So, that means it is already taken care of, and as a result the RPN value is low. But when we talk about that operates at degraded performance, its severity is comparatively low, but its probability is high and detectability is also low. So, that means the probability, high probability with low detectability creates maximum problem here, and as a result RPN is more. That means ultimately loss to the system because of this failure mode is much more compared to others. So, your efforts, actions require here. Okay. Another one, operates too long, that is also issue. Third one is the fails of while running an issue, and external leak also an issue, because these are having high RPN values. So, you know how to calculate RPN. Now, what is the documentation? The documentation part is important. See that you have to point out that failure mode and dependency for what system, subsystem and component level, what level you are doing. Then you describe it. Suppose you have taken, let it be component level, then you write down the name of the component, or subsystem level, write down the name of the subsystem and write down the comments. Usually FMEA at the component level we do when we go for say that hardware based breakdown, that is bottom up approach. But if you go by functional case, then maybe what will happen, a subsystem function also you can take and accordingly you give comments, but that functional breaking down although requires some times, but it is difficult to find out the failure modes and the other parameters. Okay. So, then you see that there are 11 different items that is to be filled up. The component which whatever you have chosen, either component, subsystem, system, what function it will perform, and then what are the failure modes. There can be many failure modes. You have seen in the compressor system, its what is the function? Compress the air to the desired pressure. Then what are the failure mode? There are 7 failure modes. For every failure mode 1, what is the effect, what are the causes and what are the current control, you have to write, and then accordingly PSD will be written and RPN value will be calculated, and that is what you have seen. Okay. And then you require corrective actions. If suppose RPN is just for operates at degraded performance, that RPN we have found out that is 168, and we also found out the detectability 7, this one 6 and this one 4. Now, your recommended action will be where? What is the recommended action? You want to reduce it to lower values. It is possible if you reduce this value or this value. Which one is maximum here? 7. So, it may so happen if you know the current controls and if you have the system knowledge, design knowledge, you may find out that there can be a possibility of putting a sensor or some kind of inspection scheme, so that the detectability part, that it is operating at lower performance, can be improved, maybe it can be improved to 3. So, that is what is the recommendation, what you should do so that detectability will be improved. Similarly, this you may require to improve it to 3. So, what you should do so that the probability of occurrence will be less. So, then 3 into 4 into 3, then this will be 3 into 4, 12 into 3, 36. So, RPN value will be reduced. So, by corrective action means this, your action may be hardware, software, humanware, or may be administrative, may be engineering control, and this can be triggered to reducing probability, reducing severity or improving detectability. So, these are the clues. Now, where you should focus? You focus on where the value is high, that there is the possibility for improving. If you find that there is no possibility that the detectability can be improved, then it will remain 7. Then it may be possible that probability 3 and maybe severity can be finally reduced to 2, something like this. So, by recommended action we means preventive and mitigative. Preventive actions, what will happen? It will improve the probability, means reduce the probability of occurrence. Mitigative actions reduce the severity of occurrence, and detectability part is primarily in the preventive side. So, it will help you in detecting that it will help you in detecting that failure mode occurs. So, that means it is in the mitigative set. Failure mode has occurred, immediately take actions. So, the action, then you find out the action. Now, where the action, if action taken, then this value will change. Now, 6 change to 3, 4 remain 4 and 7 change to 3. So, your final RPN is 36. So, you can add something like remarks here, whether this is taken place. Suppose it is closed, that means this action has been identified and action has been taken, accordingly this reduction is achieved and it is closed. Okay. So, this is basically the purpose. So, when for your own system there will be several component and several failure modes, it is a big list will be prepared. Now, another important issue is that, as I told you, that where to concentrate, that prioritization of failure mode. So, that means once you calculated the RPN, you can do this kind of bar chart. So, here 168, 112 like this in decreasing order of RPN, and then you create a cumulative value chart, and then what will happen, it will ultimately gives you that what is the this one. Actually, this you have to see this one in order to understand this. So, here although RPN values, although it is said, but from percentage wise we will be interested in 80% cases. Suppose 80% is this. So, that means these three failure modes, are having 80% of the overall total risk RPN values. So, your concentration will be first here, here and here, maybe here followed by here, followed by here. Okay. Someone may say that this is also high value. Suppose if we want to consider this, suppose if we consider, then it is basically 30%, this is the 30% case. If we consider this, what will happen? You are going like this. So, 90%. Suppose you want to see that 90% cases, then this will also be considered. Now, that is what is the use of this chart. So, this chart, the cumulative value chart, this one percentage chart, known as Pareto chart. So, that means here we are, what we are saying, although there are 7 failure modes, but 3 failure modes are creating 80% of the problem, risk issues. From the risk point of view, these 3 failure modes are contributing to 80% of the risk. Okay, where risk is RPN, risk priority number. So, I hope that you got failure mode and effect analysis. So, you just to recapitulate, first is what I say that you must have system knowledge, design knowledge, hazard knowledge and other knowledge with experience. Then there will be system breakdown is important. There will be either hardware approach or software approach. So, it is usual hardware approach or functional approach, hardware approach. Then hardware approach is easier one, it will ultimately leads to component level. For every component you find out the failure modes. So, find out failure modes. Now, whether the component failure is important or not, there is a process given to you. So, from that process you may ignore some of the components or system or subsystem. And then what happen, once you have the failure modes, the probability, severity and detectability you find out. This will be found out if you have the system knowledge, design knowledge, hazard knowledge. So, what happen probability actually from the cause, it basically if you know the causes of failure, occurrence of failure mode, then it will help you in finding probability. Severity from effect point of view, and detectability, that whether you are able to detect the failure mode or not. Then everything can be quantified, but it is a practice level issue, and you cannot wait for quantification. So, better quantification. So, what you do, you will use subjective scale. Subjective scale is used. So, in this subjective scale, 10-point scale can be used, 7-point can be used, 5-point, 3-point, but usually either 5-point scale or 10-point scale are used. Use this scale, and then what you do, find out the compute RPN, and based on RPN, then you prioritize RPN, and then you take action on priority basis. And documentation is important, because after action taken, your RPN value should be and properly document. Okay. Now, FMEA can be design FMEA, can be process FMEA, can be operation FMEA. So, FMEA can be used in different time. So, it is very powerful but simple technique to understand, but it requires team game to complete it. Okay. Thank you very much.